Up to this point, you should have been able to find the dual of a given primal LP, whether the given primal LP is normal or non-normal, maximization or minimization. So let me ask you some questions to check your understanding. The first question, if a variable, let's say y2 is URS, so that is in the primal LP, then in the dual LP, choose the correct statement. I will give you a pause on this video to give you the time to think, and then I will give you the answer after that pause. Remember that the relation between primal and dual is that if we are given a variable in the primal, it will be related to the constraint in the dual. So if the variable is URS in primal, so in the dual, the sign of the constraint is equality. The second question, if a constraint, let's say the second constraint, has the sign less than or equal to, then in the dual LP, again choose the correct statement. Well, we can't answer this question because we don't know whether the primal LP is a maximization or minimization. Therefore, we don't know whether this sign less than or equal to is normal or non-normal. Because remember that if it is a maximization case, then this is a normal constraint, which will mean that our dual variable will be normal as well. However, if the given primal is a minimization problem, then this sign is non-normal, which will make our dual variable is also non-normal. In this case, we do not have enough information to answer. I think you have seen this question before, but never mind. If a primal LP is a normal maximization problem with 7 variables and 5 constraints, then the dual LP is a normal minimization problem with 7 constraints and they all have the sign of greater than or equal to. The dual LP has 5 variables and the sign restrictions of all variables is less than or equal to. Is this statement completely true or false? The answer is false because if the primal is a normal maximization, the dual is also normal minimization. Up to here, everything is correct. And then if it is a normal problem, the sign restriction of the variable always greater than or equals to 0. Whether it is normal max, normal min, the sign restrictions is always greater than or equals to 0. So here's the fourth question. Given the primal LP, how many mistakes do you find in this dual LP? Okay, so here's the correct dual LP. And then the mistakes in this dual LP is that first x1 minus x2. So remember that the second column, x2, comes from the second constraint. The coefficients of the second constraint is plus 1, minus 1, minus 1. So this should be plus instead of minus. Okay, and then for the right hand side of the dual, so the constraints here, the constraint comes from the variable. So the second constraint comes from the second variable. The second variable is a non-normal variable in the minimization case. Therefore, this constraint should also be non-normal. In the maximization case, non-normal constraint has the sign of greater than or equal to. Third constraint in the dual comes from the third variable in the primal. The third variable in the primal is a normal variable. Normal variable should produce a normal constraint. So normal constraint in maximization should be less than or equal to. Now the first dual variable comes from the first constraint in the primal. In the primal, the first constraint is a normal constraint because it's a minimization case. the sign is greater than or equal to, so the first constraint in primal is normal. If it is normal, then the first variable should be normal as well. In the case of maximization, the normal variable is greater than or equals to 0. Okay, so that's the end of this video, and then in the next one I'm going to talk about how we may use the dual LP to gain some economic insight into a problem. So see you on the next one, and thank you.